Um, to kick things off, welcome everybody to join us for our second Akri developer meeting of 2021. Just as a reminder, all the meeting is recorded and it's going to be posted onto YouTube later, just as sort of a disclaimer. Um, so if everybody is okay with that, let's get started. For today, we have one announcement, which is for KubeCon EU 2021, our proposal got accepted, so we will be having a talk at that event. For everybody here, you can find more information about KubeCon EU 2021 here on this link. Um, and hope to see you guys there, and please join us for our session. We have quite a number of items on the agenda today, so I'll pass off to Kate and let her get started here.
Hi, everyone. Great to see so many people on the call. The first thing that we're going to talk about is a new feature that we have. It's currently sitting as a PR, but hopefully will be merged soon. And that is to enable discovery handlers to run outside of the Akri agent. So I'm going to go ahead and share my screen. Wonderful. Okay. Let me know if you cannot see my screen. Here's just a diagram of the way that our former model with Discovery Handler works. So there we go. Hopefully everyone can see this. So our Akri agent is the part of Akri that does the discovery. And previously, inside that agent was all of our discovery handlers, or also known as protocols. So you deploy one Akri agent and it would have UDEV discovery functionality, OnVIF discovery functionality, and OPC-UA discovery functionality. The problem with this is, say you only wanted to discover a USB camera using UDEV, you still would have OnVIF and OPC support there, increasing the attack surface of the agent and the size. So it's just not necessary. And beyond that, we had some community members who were adding some more protocols. In particular, DADS was implementing ZeroConf, which increased the size of the agent threefold with its dependencies. So it just didn't make sense to merge that and make everyone take on that size change. So that kind of incentivized creating this new structure of our discovery handlers, where our discovery handlers run in their own pods. They communicate with the agent over a gRPC interface. They register with the agent saying, hey, I'm here, call me if a configuration that uses me is applied. And then they also implement a discovery service that the agent will then call when a configuration is applied that asks for devices that discovery handler can discover. This does many things. First of all, it makes it so that to implement a discovery handler, you don't need to touch any of Akri's core code. So you don't need to understand it, you don't need to sift through it. And it also means that you don't need to implement your discovery handler in Rust. Rust is awesome, but it has a steep learning curve and not everyone has gotten over it. So this should open up the ability to create discovery handlers to a wider audience of people. And then more so if you have a proprietary protocol that you can't disclose, this also opens it up so that you can still use Akri to discover devices using your protocol without anyone having to see that protocol. Another ask from the community was to make discovery handlers easier to implement. So it's already easier now that we have a gRPC interface with a protobuf that you can go ahead and auto-generate code with. But we made a template to expedite discovery handler creation for Rust developers even more. It'd be great for someone to add one for Go as well. But I'm going to go ahead and quickly demo how to do that in just a few minutes. We're going to do a dummy example, so it's obviously not going to be a full-fledged solution, but you'll see kind of how the flow will work if you were to go and create a discovery handler in Rust right now. So the first thing you do is you're going to pull down our template for discovery handlers, and you also set the name of your discovery handler when you do this. So our discovery handler that we're going to be making right now, we're going to call Echo, because all it's going to do is take in the list of devices that are in the discovery details portion of the configuration. So it's just going to take in a list of devices and say, hey, I found them. So it's just kind of echoing what is applied in a configuration, or what is set in a configuration. Great. We now have created a new project. Let's go ahead and open it. Okay, so we can see we have multiple files that were automatically pulled down. One to notice first is you already have all the structure you need to create a discovery handler. All you need to do is implement that discovery logic right here. Let's just go ahead and add that. So for us, I'm just going to paste in some logic. All it's doing is, let's take a look at the request that's sent from the agent. So when the agent calls discover on a discovery handler, and remember, this is prompted by a configuration being applied that asks for devices that discovery handler can discover, it passes this discover request. So if we look at it, we can see that this contains some discovery details. This is the map of information that is set in a configuration and passed from the agent to a discovery handler. So it should contain all the information a discovery handler needs. So in our scenario, that information is just what are the values of that map, because we're just going to say we discovered whatever the value names of that map are. So we're just going to get the values, and then we're just sending a list of devices back to the agent saying, hey, we discovered those. So just a really simple dummy implementation. The only other step you need to do as a discovery handler developer for this REST template is you have to decide the name of your discovery handler. So when a discovery handler registers with the agent, it registers under a certain protocol name. So for us, we'll say Echo. So if a configuration that uses that protocol name is applied, all Echo discovery handlers will be called. Their discover functions will be called. So we're specifying a name of Echo, and the only other thing you have to do is say, does your discovery handler discover local devices that are attached to local nodes or embedded in them? So think a USB camera or maybe a GPU. Or does it discover network-based devices? So think IP cameras, OPC UA servers. So doesn't really matter for our dummy scenario, but we'll just say every node has its own Echo devices. And finally, the only thing you have to do is build it. So we already have a Docker file made for you. And we can just build that. Great. And now we can push that latest build. And then I have a cluster here. You can see it just has one node. So it's just a single node cluster. But we can go ahead and now install Akri using this new modular agent. So with one agent and one discovery handler for Echo discovery. This is more verbose than it'll be when this is in prod. It's because I have this locally being developed. So I have custom builds for the agent and the controller, and I'm using my locally packaged Helm chart. So these first 5 lines will basically disappear. But the thing to note is when you implement a custom discovery handler, we have Helm templates for a custom configuration and a custom discovery handler daemon set deployment. That template's called custom discovery. So if you want to apply automatically a custom configuration, you just set custom discovery to be enabled. You set that protocol name that we specified in our discovery handler, and that's telling the agent to call all discovery handlers registered under that protocol name. And then for our discovery, and then you set any information that's needed to be passed to the discovery handler in that discovery details map. So for us, that's inside the discovery details, we specified the name of the 2 devices we want to kind of Echo discover. So we're going to discover a food device and a bar device. And then you tell Akri's Helm chart to automatically deploy that daemon set with your discovery handler. So we're saying set discovery to be enabled, call that daemon set Akri Echo, and then here's the image we just built. So we want that to be the image for all those pods. So we can go ahead and apply that. And we're going to see, as expected, the agent and controller are spinning up, but also which is new, we also have our discovery handler pod spinning up as well. And now we can see that Akri discovered those foo and bar devices and created an instance for each of them. They're now being advertised as Kubernetes resources that you could schedule pods against, or you could have Akri automatically deploy workloads to them. And the cleanup is normal. If we were to delete that Akri echo configuration, those instances would go away. And if we were to delete Akri, everything would clean up. That was a really fast overview. Are there any questions on this? Great. I'm going to go ahead and clean it up then real quick just to show how that works. You can see how those instances were deleted and everything's back to a ready state where we can now apply another configuration. And just a further step, if we delete Akri, then everything's going to clean up and be back to a clean slate. Cool, I'm going to stop sharing there. Are there any questions in general on, maybe not on the demo, but discovery handlers and how that's being, how we modularized all of that and the implications of that?
One quick question on the discovery handler. So it's basically just a gRPC server with some kind of gRPC interface that you defined, and as long as I can fulfill this gRPC interface with, I can just basically write my discovery handler in the language that I choose, right? So it doesn't really matter if it's Go, Python, or whatnot. We can use everything, right?
Exactly. It's kind of analogous to Kubernetes device plugin interface, where you could write a device plugin in any language as long as it implemented those needed functions. So it's the same.
Oh, nice. Okay.
Yeah. Great. If there's no other questions, I'll pass it, Edric, back to you, and we can move to the next items on the agenda.
Yep, wonderful. So the next item that we have on the list is the dependency update work that Roa has done. Roa, do you need any sort of screen sharing? If not, I'll just share the agenda.
Thanks, Edward. I think that's okay for now. So let me give at least an overview of, what auto-update dependencies is and why we need it. So as you all know, any project has a bunch of dependencies, and Akri is no exception. Actually, Akri has a lot of dependencies. Everyone can tell that by just looking at the cargo log file we have. So with dependencies comes some risks, right? Because you're depending on other libraries or crates, and those libraries can have bugs, can have security vulnerabilities, and can have performance issues as well. So it's really important to keep our dependencies up to date. And for now, dependencies update has been really a manual process where somebody would need and go update the dependencies. So what the work I did do is automate this process, so it's kind of streamlined and the team doesn't have to worry about it. So this is done through like a Github Action that we added that has the ability to run an update command and a verify command, and then check if there are any new updates that we can take, and then if that verify command succeeds, then those updates are a pull request is created with the recommended dependencies to update. So with that, I think I introduced a new Akri contributor, which is the Akri bot that takes care of running this workflow once a month to make sure our dependencies are kept up to date. So you'll start seeing pull requests that are created by the Akri bot every month once dependency update is detected. One thing worth mentioning, this is done through a GitHub Action. the GitHub action is pretty generic. So right now we use Rust mainly for code base, but it can be extended, like it can be used for other languages, because at the end of the day, it just takes an update command and a verify command. So if you have other projects, use Go, JavaScript, or others, you can take a look at the GitHub action and see if it's useful for you as well. So yeah, for that, that kind of sums up the dependency update. I can try to project that helps to look like how that works.
So Roa, if you're gonna share screen, I'll make you host, okay?
Okay, thanks, Eric. One thing that's worth mentioning is, as part of this effort to make sure our dependencies are also always kept up to date, we also added a check as a workflows, which does security audits for dependencies as well, to make sure any new introduced dependencies do not propose any security vulnerability. So that's worth mentioning as well, as part of the effort to keep Akri up to date. So with that, I'm trying to share my screen. Can you guys see it now? Okay, hopefully you can see it. Okay, awesome. So this is an example pull request that was automatically created by our Akri bot. And it does have a bunch of dependencies updates to our cargo log file. So bottom line, if any package uses some versioning, we'll be able to take those dependencies automatically, and for major updates, we'll have to do them manually. And with that, I think I can get it back to Adric.
Wonderful, thanks, Roa. That's a pretty awesome feature to be to have now. So let's pass it on to Brian to talk a little bit about webhooks. Brian, will you need screen sharing?
Yeah, sure. Just a little bit.
Alrighty. Roa, do you want to make Brian the host?
Sure. Any tips?
If you go into participants, it should pop up.
Yep.
Awesome.
Ready. Let's see. So how do I share my screen? Let's see. I'll share here. Okay. Am I muted? No. Okay. Webhooks, what we're calling webhooks, is really a way to validate configurations that are passed to Kubernetes and passed on to Akri. Really, because we encapsulate a full pod spec and 2 service specs in our configuration, validating it is kind of a tricky thing. We could have created an entire pod spec and service spec and put it into the validation of, or the explicit validation of our CRD. But there's actually, for some of the base resource types, there isn't an example YAML file of what a pod spec looks like, or it's really, really, really big and unwieldy. And it would tie us to a particular version of Kubernetes. So we looked around for another approach and stumbled across the idea of an admission control webhook, which is pretty cool. You sort of tie it in, you create this service and notify Kubernetes that for the API server, when it gets an incoming request, hey, trigger my webhook and let me say yay or nay to this incoming resource. So when we found that, Daz, in his like industriousness, like took this on, and there is, and I'm not going to do justice to the work he did here, and I apologize for that, but I'm trying. Took on this like kind of sort of documented feature in Go specifically, and found a way to port that over to Rust and get it working, so that now when you use our admission control, or our, I think we called it, I'm not even sure, with the admission controller, our webhook, when you use it, if you submit a configuration that, say, puts the resources, the resource request in the wrong like indentation level, we'll be able to figure that out and tell you and reject the configuration as you're not getting what you're asking for. So it's really easy in a YAML file where everything is controlled by indentation to accidentally put these things at the wrong level. And unfortunately, the parsing engines behind, or maybe fortunately, I don't know, behind a lot of the resource definitions, or the API server, are so permissive that they just sort of like, oh, that's a setting that I don't recognize, I'm just going to ignore it and go on my merry way, which is really, it's a durable system, but it's really hard because you have, if you've done this, you have submitted a resource definition and said, hey, this is what I want. And you've gotten no feedback that says you're not going to get it. You've just gotten this positive feedback back. So you're expecting to get it, and yet you might not be getting the behavior you want. And so having this validation, this way to check what the person is requesting, and what the webhook actually does is it parses that request into the objects that Kubernetes understands, and then, or it deserializes it into the Kubernetes object, and then serializes it into YAML again, and then compares the incoming YAML to what's been deserialized and reserialized. And so by doing that, you can then kind of walk the YAML and see, are you getting what you expected to get? And so for the case where you might improperly indent something, the settings that you have improperly indented won't ever make it through the serialized, deserialized. So they'll be absent in that output. So when you compare the two, the input and what reality is, you'll see a mismatch and be able to say, oh, something's gone wrong here. Someone's not getting what they're asking for. So that's what we've done here, or that's what Daz has done here. And down here at the bottom, we can see just how simple with the Helm chart it is to actually deploy that. So with a couple Helm chart settings, you can actually enable this in your Akri installation. And now you've got some, you should have some feeling of certainty that you are in fact deploying the Akri configuration that you think you are, and that Akri is in fact doing what you want it to do, or it's getting the inputs that you expect it to get. So this was super awesome, and we're stoked to have it in, and hope that people use it. And if they find ways to improve it, that we get issues and feedback accordingly. So yeah, that's what I got. I can pass it back to Edric as the, I think, let me figure out how here.
Awesome. So going through the agenda items, the next thing that we have is the work about deallocate, and that's back to Roa.
Thanks, Edric. So before I jump to deallocate, I just noticed I didn't really paste the link about the auto-update dependency GitHub action. So I'm going to send it now in chat. Feel free to use it for any other project. Would love to your contributions as well. So now back to the agenda about deallocate. A little bit about how Kubernetes device plugin framework works. Right now, the way it works is once the Kubernetes component called the scheduler detects that it can schedule a resource and resource available for it to schedule a pod to work to, it will then communicate with the kubelet, which then takes care of talking to our agent, Akri agent, to say, hey, I want to allocate a resource, and then Akri takes care of, making sure there's a resource available through or like discovering the resource through its discovery handlers, and that's all taken care of Akri. However, one problem we have right now is Kubernetes does not have an equivalent deallocate. So let's say right now a resource goes offline, or like actually on the other side, a pod using your resources goes offline. So right now we have some logic in Akri that kind of is a best effort logic that takes care of detecting those deallocates and then deallocating the resources and say, hey, this resource is no longer used. So one thing we've been looking at is working with the Kubernetes folks to try to have an equivalent deallocate function. So it looks like there are existing efforts from other Kubernetes contributors and community members to try to have that as part of Kubernetes instead of doing that in the different layers and the device plugins. So with that said, there's currently a CAP, or like a Kubernetes enhancement proposal that's in review, and we're kind of supporting that from Akri's side to make sure this is pushed hopefully to the next Kubernetes version. And just to kind of give an update what that means for Akri, I think what it means is, as I mentioned, right now, detecting those deallocates is a best effort. So you can end up with some lag in, let's say a pod no longer uses a resource, and then it might take you up to 5 minutes to be able to reuse that resource back. So having that support in Kubernetes will allow us to cut down this 5 minutes to instantaneously reuse the resources. So that's what it means for Akri. So we'll keep everyone posted with updates, but that's something we're working on improving and hopefully streamlining the Kubernetes as part of Kubernetes as well. Back to you, Edric.
Wonderful. So next we have the CoAP protocol. Giovanni, do you want to talk a little bit about that?
Yes. Can I share the screen? It's not necessary, but I think it may help a bit.
Yeah. Let me make you host, and then you should be able to share the screen.
Okay. Okay, should be able now. Let me close some windows before. Okay. Okay, can you see the screen?
Yeah, we can see it.
Okay. So I'm not sure about the pronunciation of COPE. I think it's COPE is the right pronunciation. Anyway, it's a constrained application protocol, and I think it's interesting because it's basically REST but based on UDP instead of HTTP. So it's a very small protocol for constrained devices. And in my pull request, I supported both this protocol and the other standard called CORE, which stands for Constrained RESTful Environments in Format, which is just a way to make the devices discoverable in the environment. So, and this is important because this is a standard which allows the device to define which resource it has available as just the REST resources, and it's meant for machine-to-machine communication. So it's meant for device to be discovered, for instance, by Kubernetes without human intervention. So a device could go offline or could be added to the cluster, to the environment, and there could be a lot of them. And it's important for the system to be able to discover these devices without human intervention. I think that it's a very important feature or requirement of any system working on the edge. So about COPE is very lightweight, and for instance, I have bin able to implement the protocol in Rust, and there was already another implementation, but it was a bit, it required a bit of work to make it work on embedded devices, but with the help of this guy called Martin, we were able to write an implementation suitable for embedded, which means that it can run on no standard, without a standard library. So for instance, I have been using this protocol on my embedded device, which is STM3407 Discovery, which has, so this is how it looks like. And it has only about 100 kilobytes of RAM, and it's already considered a good amount for embedded devices. So in this case, in these use cases, for protocols like HTTP cannot be implemented because they would require too much memory. For instance, if you just look at, for instance, maybe Zelda. I think CERD, for instance, comes to with a size of about 500 kilobytes, just to implement a serial user protocol. Whereas COPE messages packets are usually with a size of a few bytes, only a few bytes. So the whole protocol is meant to be used by very constrained devices. But despite being for constrained devices, it's also very, I could say, high level, because it's meant to be used as REST, so it's not a low-level protocol. And so the advantages of using COPE could be also listed as the advantages of using, I think, REST in general compared to other protocols. For instance, that means that so if you have I think it's very good lecture reading the original dissertation by Roy Fielding, the author of the REST protocol. And the REST protocol is basically client-server communication, which has some constraints, some requirements or features. For instance, it is stateless compared to other protocols. And that, I think, is also important for constrained device, for edge devices, because it means that the device can lose the connection to the network, can go offline, and then go back without storing any state. For instance, my embedded device doesn't store any, it has a flash memory, so it cannot, for instance, save some information on a file system. It doesn't even have a file system, so it's impossible to store anything. And also, the REST protocol is very useful because it's meant to be used with, I think, I'm not sure if it's mentioned here, but maybe it was in another part of the dissertation. But it's very also important to support a proxy in RESTful architecture, because, for instance, even in the case of Akri, I have been able to just write a broker which translates HTTP request to COPE request, and so it's very easy to do because the COPE works just as HTTP. And it's important because this allows the pods within the Kubernetes cluster to communicate with devices outside of the cluster. And in general, proxies are important because they allow to communicate, to translate messages between devices on different networks, which could be, in my opinion, important to edge devices. And so let me see, I wrote down a few points. So, okay. So it's lightweight, but it's based on the UDP, but still it has a lot of nice features compared to other protocols. For instance, MQTT is also a very common protocol in edge computation. And but for this paper, which compares the four most common protocol, which are COPE, MQTT, IMQP, which should be a message-based protocol with queues, very similar to MQTT, and HTTP. So COPE is the one that has the lowest overhead, because a packet is just a few bytes, and the whole protocol, I think, is the standard can easily read in maybe 1 hour. It's just, I think, yes, just 100 pages, and I think it's very useful to understand the use cases. It's also, it requires not a lot of resources compared to other protocols. Has a low latency because it uses UDP and not TCP, and it's the interoperability is very high because it works like REST. So it's easy to use, such as just like HTTP. So if anyone knows HTTP, I think and almost everyone knows HTTP. It's very easy to get started with COPE also. And that's it. So if you I don't know if you have any question.
Thank you so much for sharing all this. I did not have a sense of the latency and size benefits of COPE. So it'd be great if you could add these articles that you referenced to our meeting notes, because I think I would like to take a deeper look at them, and I think others might as well. Really cool to see like the type of constrained devices that Akri can discover with COPE. So thanks for all the work you've been doing on adding this protocol.
Yeah, you're welcome. Okay, sure.
Awesome. So going through the agenda, I think before going on to point 6, I see a couple folks from RWTH here. I'm curious about sort of how you guys kind of came about Akri and thoughts about the project, as well as sort of the scenarios that you guys are looking at, and if there's any sort of questions or comments that you guys have in general.
Yes, sure. Yeah, thanks that we can be here, basically, first of all. We basically discovered you because of the Kubernetes podcast. I think Kate did a few weeks ago or a few months ago. And basically, we thought that the project you guys are doing is basically, or is supporting the use cases we are doing in our research from RWTH. So what we are researching at the moment, or what Michael and I are part of, is a research project called Internet of Production, which is one of the let's say, largest research groups in Germany regarding manufacturing systems and, let's say, digitalization in general, whatever this means. And what we have been doing in the last few years, or in the last 1.5 years, is basically setting up a Kubernetes cluster for machine data, for machine connectivity. And since, of course, our project is quite big, so we have, I think, about 170 scientists with different machines, different manufacturing systems. So we basically have everything from welding over smiting over to laser processing. We have textile, so weaving, a bunch of different machines that we all want to basically connect to one single Kubernetes cluster and then aggregate the data. Which of course comes with the problem that you somehow need to like connect all of that. Especially stuff like OPC-UA and all these protocols that are being developed at the moment can help with that, but we haven't really seen a way to efficiently do that, especially on a larger scale. I mean, it's all fun when you know your devices, basically, but it gets terribly complex once you have like a bunch of different devices with different protocols and so on and so on. So you need some kind of management system for your connectors for your machines. So that's basically the main idea of our project. We're just getting started, basically. Our infrastructure is set up at the moment, and we're currently looking into different ways of how to actually aggregate the data. So we've taken a look on FluentD and what was the other one? Node-RED, Michael? Yes.
Yeah, that would be one endpoint. Try. We have the huge problem that the people operating the machines are all mechanical engineers and have no idea of networking protocols or anything. So on that end, one idea was to make it as simple as possible for them and use Node-RED and then probably write out data or the machine's data in Kafka and from there on distribute it in the cluster. And one of the ways was FluentD, Kafka, what else? Kafka Connect, Camel, the whole set of protocols.
Yeah. But of course, another good way would be to have like all the connectors for your machines basically managed by Kubernetes, and then you just plug them into your machine and you have some kind of auto discovery handler that Kate just described, for example, that automatically sees your machine, basically downloads the code and everything runs. That's basically like when I talk or when I speak about it like that, it sounds like a huge amount of effort. but I think or what we saw is when we hear the podcast and why we are basically sitting here now is that this could be a viable option on actually, let's say, connecting all of these machines. And since we are basically in a research environment, it's nice because we can actually like play around with our machines. Normally, when you have, I don't know, Volkswagen, Audi, or Airbus, they don't really like people messing up their machinery or their manufacturing systems because they typically pay a lot of money for that, and they don't want to have like their $2 million machine being stopped because somebody needs to implement a protocol. So that was the point where we thought, yeah, maybe we can help each other out. But as we said, it's still in the early beginning. So we're just seeing or scouting for different technologies and so on, and seeing what could work, what we actually can handle with our little task force, of course. But yeah, that's a basic idea from our side or our use case, especially compared with in addition to Akri.
Mm-hmm. And I think.
Oh, sorry.
Oh, go ahead.
I was just going to say, just to reiterate what you were saying to make sure I understand the scenario or the baseline scenario. It sounds like you want to discover this variety of machinery and then without having to change anything on the machinery. Whatever protocol the machine already speaks, let it speak that. And then once you've discovered it, you want to automatically deploy some workload to it that can grab data from it. Is that the idea?
Yes.
Okay. So in Akri terms, that would be have a discovery handler for each type of protocol the machines speak, deploy that to your cluster, have set some workload that grabs data from these machines for each type of protocol, and have Akri automatically deploy that to each one. And then I could see those workloads, which we call brokers, exposing some service so that then that data can be aggregated from all of those workloads and pulled and analyzed by your research group. Does that seem to fit the scenario?
Yeah, like right now we're basically doing a push method, like we have FluentD just pushing into a Kafka stream. So we just get rid of the data as soon as we can, basically. So we don't overwhelm the machine. So you don't like need to buffer and then stuff like that. But of course, I think a similar concept could be implemented with Akri as well. The basic idea right now is that nobody actually built that kind of system on that kind of different machinery yet. So we are basically in the point where we just want to aggregate at the moment as much effort as we can, but also on the other hand, want some kind of pipelining that we can change later on very easily without driving to, I don't know, 30 different institutes and setting up new Raspberry Pis there. So having some sort of system which can handle, on one hand, device detection or device discovery, but also can change the aggregation method. Like, for example, when you have a temperature sensor, it might be that it's in the first year, it's really important that you measure it every second. And then after a while, you figure out, oh, maybe every 5 seconds is enough. So I just like kind of dial in all of these numbers. And what we are a little bit scared of right now is that we kind of implement all these devices, and then in, I don't know, 2 years, 3 years, somebody wants to change something and they have to like log into all of these devices and change the code that is running on there. So we need some kind of mechanism that handles data aggregation, but in a very flexible, changeable way, let's say it like that. And of course, service discovery is a must-have, basically, because you don't want to have like floating devices in your network that nobody knows what this actually is. But yeah, so it's complex because like you have like a bunch of different people on one hand working on the machinery, on the other hand working on the databases, on the architecture. So everything is just like coming up at the same time, and we still have to still figure out how to actually use that stuff. Since, let's say, Kubernetes is not the most user-friendly infrastructure. So it can be a challenge to promote that. Let's put it like that.
So just curious, do you guys right now just manually add every node to the cluster? Is that how it works?
Right now we have basically an ingestion Kafka broker where we just dump everything that we can, basically. So it doesn't really matter what is running on the edge or what is running on your device. You have just like your one edge device that is either the machine itself or some Raspberry Pi connected to your PLC system, which basically grabs the data. However, like, I don't even care. Like, just give me the Kafka message or the JSON message, and then we route it depending on what stream it comes in, basically. But of course, that works for the beginning, but this will not scale. And that's why we're sitting here.
So I think, Shan, you also messaged that you have the similar kind of viewpoints as Moritz and the work that they're doing. Do you want to sort of talk about your scenario too?
Hi guys, so this is, first of all, I'll introduce myself really quick. I'm Shan, my first meeting ever with you guys, so glad to meet you virtually. As Moritz and Michael already mentioned, so I am part of the same geographical region, so I'm actually from Germany, and we work on the same problems that Moritz already is mentioning, so bringing the industry, so to say, to the cloud, and like fostering systems there and within this whole ecosystem. So yeah, for us, it's practically the same issue. What Moritz is mentioning is the fact that companies have machineries. Lately, they've been realizing the fact that that it's becoming very critical for them to be engaged in this whole digitization phase, and there's no other way, for example, than consulting, so to say, researchers, getting some grips on what the current state of the art is, and then how they can proceed in the upcoming, let's say, X years. X could be 5, maybe even 7, and somehow get their whole production systems and all service systems more efficient in terms of IT infrastructure and so on. and Akri pretty much looks promising. I've been looking into the repositories, and I've actually got to know about the project through some I think posts made in some other forums. So it was quite interesting to look into it. And then I'm part of a couple of projects, international projects, where we'll probably be looking at getting some possibilities of deploying Akri in some, let's say, test system. So I am a research scientist, so that means I work in an institute where we do have the benefits of, so to say, working near big robotic arms as well as certain industrial machines. So that's good enough. So you can play with it without having to worry about destroying anything or setting something on fire. So we probably might see the project quite promising in the upcoming year, so to say.
Wonderful. So kind of on all sides, we would love to see how kind of you guys integrate Akri, as well as we're always here. Please reach out for any sort of questions, thoughts, any kind of concerns. We're here to help. So any sort of feedback, any sort of questions, please reach out. We're always on the Slack channel.
Can I add something to this discussion?
Absolutely.
Okay, so for my thesis at Padova Italy University, I have a similar use case of Maurice and Sean. And in particular, Sean said he would like to bring, at least from what I understood, he would like to bring the edge to the cloud. Whereas in my case, I'm trying to bring the cloud to the edge, which is the contrary. But the idea is that I would like the topic for me and my professor is called the Continuum of Computing, which means that we bring together all the different parts of the network, the cloud, the edge, and the fog. And the idea is that, so for instance, you can deploy an application to the edge, and it is deployed on Kubernetes cluster, and it works just like in cloud. So you have all the advantages like high availability, automatic provisioning, easy deployment, but you can also use edge devices as just any other service. So for instance, if you have an application which needs data from local devices, like for instance, sensors in the city or any other industrial use case, you can just use them as just any Kubernetes resource. And in particular, I also had the same issue of Maurice about how to update the code on the devices without bringing them down, without stopping them, because that would make the company lose money, and they don't want that. And for instance, in my case, I have devices which collect data, and then this data is run in the cluster, and I run a machine learning prediction, the cluster. But there are several papers which mention about the fact that if you are able to pre-process the data before sending to the cluster, you can decrease the amount of bandwidth, but also increase the accuracy of the prediction. Because if the device which collects the data is able to run a custom module, a custom pre-processing module, then you can increase, you can have a lot of benefits. So this is just another use case of the requirements of. It would be nice to update the code on the devices, and the embedded device. And in my case, I thought that the best solution with the state of art of technology would be using WebAssembly. So, and indeed, I have mentioned sometimes in the Akri issues that I also work with the Crustlet, which is another project of Days Labs. And in particular, with the Rust, I have been able to run a WASM interpreter, which requires a low amount of memory compared to WASM compiler, which requires much more memory. And in this way, I am able to write a WASI module, which defines how to pre-process the data. And I can update the module on the embedded devices connected to the network without turning off the device, flashing the device, and turning it on again. So I can update the code run on the device without stopping it. So that's it.
That's really good feedback. I think it's really interesting that sort of everybody's view on the problem resonates with each other, and there is definitely like a problem there that needs to be solved. So definitely we love all this feedback, and however you choose to integrate Akri, please have us involved. We can definitely help out, and we definitely want to know what you guys are doing, and definitely want to take iterative feedback and make Akri as applicable and as usable as possible. So
just to follow up on that, I think it sounds like we have some good ideating happening here. We have this HackMD where we've been putting some like use scenarios for Akri, and just it's a place where people can kind of brainstorm their ideas. So it sounds like maybe Giovanni, maybe Moritz, maybe that's something that you could write up your scenarios and kind of comment on each other's. It sounds like you, and same with you, Shan. It sounds like all your ideas are worthy of sharing with each other to kind of kickstart each other forward, and see if that overlaps with Akri and how as well. And also I think diagrams from everyone would be helpful. We've been saying a lot of words, but I would love to like see what's happening in each of y'all's work, and then that probably could help us as well.
Yeah, that's a really good point. I'll drop a link to our HackMD again in the Slack, which will, if you just log in with GitHub or whatever kind of authentication, you'll be able to create a new note, and then yeah, we'd love to see all the stuff that Kate mentioned. So I think this brings us to the top of the hour. Are there any more questions, comments, feedback? Okay. If not, I think we can end the meeting here. Thanks everybody for joining us. We would love to see you in the next meeting again. This meeting runs every first Tuesday of the month. So I think next month's will be in April 6th. And I'll send out a notification on Slack, on Twitter, just to remind everybody when that will be coming up. Once again, thanks everybody for showing up.
Thank you. See you.
Bye.
Hi, everyone.
Bye-bye.
Bye-bye.
Thank you. Bye-bye.